quotient rule, especially now at the beginning of your journey with it, write down, I love low d, high, minus, high d, low over what? Low squared. So when you do this, the low function is there, right? And the high function is up here. So I literally do this. That would be a great thing for you to do, and then just to keep track, because simple stuff will sink you on this. What do you think the most common simple mistake is when using the quotient rule? What one sign do you think people mess up? Yeah, they change it to plus, and then sometimes in the product rule they turn it to minus. You know, you got to remember for the quotient rule, it's minus, it's minus, it's minus. So on this one right here, there's a lot of basic simplification you can do. There's a lot of basic simplification. How do you know there's basic simplification in here? What do you see that's in all of the terms? 2 to the what? 2 to the x, yeah. So you can factor that out. You can also factor out 17e to the x. If you see common terms, factor it out. So those things right there, factor out.
Can you just cancel out the 2 to the x though?
That's what they do. Look what happens from here to here. Look what happens from there to there. So it's squared right here, and then what does it become? The square cancels, and it's just 2 to the x now. So yes, one of them cancels. That cancels right there, and this would be the awesome simplified form right there. That would be the awesome simplified form. I'd like you to go to that. That's 2 more steps. Yes, 2 more steps. How are you feeling about left? 1 is left. It doesn't become 0. You have to multiply it times something in order for it to still exist. Yes, Alex.
On the other.
Yeah, which one?
On the second page.
Oh, and the other, let's go to the other homework assignment. Sure. The other half of it. Yeah. So for the blue work, does that look familiar? It should, because we just did something very, very similar to it. So when you do that factoring, you end up with this is the derivative, right? But to know where it's increasing and decreasing, what do you first do? You set it equal to 0, because after you know where it's equal to 0, and you know all of the places where it's equal to 0, everywhere else it is not equal to 0. You've done this. Remember what I told you? If you're ever lost in a calculus question, what do? Take the derivative, set it equal to 0, and solve. Seriously, it's the most common maneuver. So you.
Wait, I have a question about the blue.
The blue? Yeah, go ahead.
When I was doing this, I skipped the middle step.
That's fine. Did you go straight to this?
Yeah.
That's fine. Totally fine. Totally fine. I will end up doing that as well. It's in here in the answer key so you can see where it comes from, and I try to do that as much as possible. Now here's the thing. How did they get so simply? How did Ms. McCullough get so simply from this line to this line? How did it go to these 3 things right here?
That's where x equals 0.
It's the 3
It's the 3 pieces, right? But when does a fraction equal 0? When does a fraction equal 0? When the top equals 0, right? So if you have 2 things being multiplied together on top, one of them has to be 0 for the whole fraction to be 0. So that's this one and this one. Why are we checking this one though? That's not the numerator. Why are we checking that one? What happens if the denominator is not 0? Yeah.
Because when you're doing your increasing and decreasing, you can't include that.
Yes. Remember critical points? Remember that term, critical points? It's where the derivative is 0 or undefined. You can't, 0 isn't in the domain, so you also have to put that in your, what's this called? Sign diagram. So what are the 3 values? Well, when does 2 to the x equal 0? It doesn't. Why? 2 to the x is always what? 2 to the x is always greater than 0. Exactly. So it's never, right? What about x ln 2 minus 1? Well, that's about 1.44. And then it's undefined when x is 0. So what are the 2 values you need to put on your sign diagram? 1.44 and 0. So that's where these 2 numbers come from right here. 0 and 1.44. And you make your sign diagram. What's going on here is each piece is being found, the sign of each piece is being found right here. And when you multiply the pieces together, you get the final sign. So for example, right here, you have positive and positive, negative, positive. So if you multiply a positive, a negative, and a positive, what do you get? A negative. And then if you have positive, negative, positive, you still have what? Negative. And then positive, 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 you have. So where is it increasing? 1.44 to infinity. And then where is it decreasing? Negative infinity all the way up to 1.44. And where is it not differentiable? Where is it discontinuous? You can't differentiate it at what? 0. Because can you plug 0 into the denominator of the derivative? Nope. So those would be the 3 things I'd be looking for. Those are really important. Fight here is because this region contains 0, right? But with this caveat. If you didn't do that caveat, it would kind of imply that you think it's differentiable there. You understand what I'm saying? So I would like you to specify, but I wouldn't count it as wrong. When we researched this for the AP exam, it's important because the AP exam asks, like, where is it increasing, where is it decreasing? And they have to be very, very clear about the grading rubrics on the AP exam because 350,000+ people take it, right? You have to be very consistent because you need to have comparable scores. So what does the grading rubric, this jumped, I'm sorry. What does the grading rubric say about that? They just avoid asking questions where it's ambiguous like that. So they'll say like on the domain of the derivative, or they'll just ask for a part of the domain, or they won't give you a question like this and ask that kind of question. Okay, and finding the derivative, what could you do first? What could you do first?
Factor.
What's the opposite of factoring? Just multiplying. So on this one, you could multiply it out. Don't forget that you can multiply some of these out and get something that's simpler. Is that always the case? No. And that's why the product rule, one of the reasons the product rule is useful, sometimes it helps you not have to multiply something out. But in this case, is it easier just to multiply it out and do the derivative? If you do this, if you multiply this out, you end up with this. It's the difference of squares, actually. It comes out really nicely. It's x to the 4th minus x. And then when you take the derivative, hey, is that nice? Theoretically, could we use the product rule on this? Do you want to see what happens when we do? It's good practice.
Wait, so how did we get x to the 4th minus x?
Because because what is x times x squared times x squared is x to the 4th, right? And then you get plus root x squared minus root x squared minus x at the end. What cancels in the middle? So you do get this, but let's use the product rule just as practice. What's the first function? What's the first function going to be? Right there. What's the second function going to be? 2x squared plus x. Yeah. So for the product rule, it's the derivative of the first times the second plus the first times the derivative of the second. So if we use the product rule right now, product rule, can someone spell it out for me? What's f prime going to be? What's the first piece going to be? 2x minus what? Well, root x is x to the what power? 1/2. So what do you bring to the front? 1/2 x to the negative 1/2, right? Times what? X squared plus... No, you do the derivative of the first times the second, remember? I'm going to write it as x to the 1/2. Plus what? Plus what? Now what? X squared minus x to the 1/2 times what? Plus half x to the negative 1/2. So that looks ugly. Theoretically, what do you expect that to simplify to? -1. You expect it to simplify to 4. Let's test it out here. We have to be very careful with the multiplication. 2x times x squared, what's that going to be? Cubed. And then this times this is going to be plus 2x to the what power? What power? To the 1 there and to the half. 1.5. And then what's this going to be right here? Minus, you're multiplying here. What's that going to be? Minus 1/2 x to the what? X to the what? 1 3/7. You add the powers, kids. 3/2. And then you multiply these together, and what do you get? Minus what? 1/2 x to the what? No. What's negative half? It's to the 0. It's to the 0. Do you see that, everybody? Okay, do this for me. This is great practice. Do this. You have to do the second multiplication. Do this one for me right now by yourself. Do that one for me by yourself right now. Can someone tell me what's the first term going to be? What? This and?
2x.
So you're going to get what? 2x cubed. That's those two. And then you do this time, like this times that one. What's that one going to be? 1/2 to the 3/2. And then the middle two. What are the middle two? Minus 2x to the what? 3/2. And then what's the last term going to be? Minus 1/2 x to the 0. Now there's some magical stuff that cancels. What cancels now? This cancels with that because you're adding them together, right? And then what else cancels? In the middle, those cancel. What is negative 1/2 x to the 0? What does that equal?
1/2.
Negative 1/2. And what does this equal? So when you put all the pieces together, there are 4 pieces left. What is left? 2x cubed, negative 1/2, and negative 1/2. When you put all those together, what do you end up with? 4x cubed minus 1. Is that the same thing? Is that what we wanted it to be? Absolutely. This is absolutely something I could ask you on a test. I could say, do this, multiply it out first and do it, and also use the product rule and show that they're the same. Now, if I asked you to use the product rule, what would be really important for you to show? All of this. If I tell you what the answer isn't what I'm looking for. What's going to be the important thing? The work. Let's say I asked you about this function right here. Given g of x is equal to 2x plus 3 to the 100th power. Why is that something that would be really, really annoying to find the derivative of? Yeah, so right now, without any more information, what would you have to do in order to do that derivative? You'd have to multiply that out. Is that something you'd ever want to do? There are actually quicker ways than you've ever seen to do that, but it still takes a while. You can use Pascal's triangle and expand that, but how many terms are you going to have? A lot. Just say a lot. You're like, I don't know, but you're going to have x to the 100th, x to the 99th term, x to the 98th, right? You don't have a way right now. Yes?
Why can't you do like the a to the x, ln a times a?
Because that right there, that rule that you're talking about, only works with a constant in the denominator. This is a constant right there. That's a really good question because you're tempted to use rules that where it looks like you can. It's a constant. Is the base a constant here? Is this a constant? It's not a constant. It's not a constant. Well, you know that this is true, so you're like, oh, maybe it's just ln 2x plus 3 times that, right? Seen it before. There's something called the chain rule, which helps you deal with the derivative of the composition of functions. Let's look at this. Let's look at this over on the side here. F of x is equal to 2x plus 3 to the 100th. That is one function plugged into another. What do you think the inner function is going to be? What do you think the inner function is going to be? We're going to call g of x the inner function, call it 2x plus 3. What's the outer function going to be? We'll call it j of x. What's the outer function? X to the 100th, right. So what would that be in terms of j and of g and j? That would be j of what? G of x. You are plugging g of x into j. Are you okay with what I just wrote up there? What are you doing here? You're taking g of x, and wherever x is here, you're taking this and putting it in for wherever x is. You see this right here? Are there sometimes multiple ways to break it apart into two functions? Yes. But this would be the most straightforward way. The rule I'm about to teach you helps you do derivatives of functions that look like this, j of g of x or f of g of x, or something where there's a function inside another. So going back here, we don't have to multiply this out. This is what the chain rule says. If some function equals f of z, and z is a function, everybody, the derivative is the derivative of the outer function evaluated at the inner times the derivative of the inner. That seems really complicated, but it's really not. Written over here, this is what it would look like. Right over here. This is what it would look like. The derivative of j of g of x is going to be the derivative of j evaluated at g of x times g prime of x. You multiply by the derivative of the inside. So let me show you how that plays out. On this one, what is the derivative of j of x? What is j prime? What is j prime? Tell me what j prime is. Raise your hand. What is it, Chris?
100 to the x.
J prime of x is 100 times what?
X.
To the 99th. What does this tell us? What do we plug into j prime? What is g of x? Oh, it's right there. So j prime of g of x, what is that? 100 times what? To the 99th. But then what do we have to multiply by on the outside? G prime. So j prime g of x times g prime of x will be what? 100 2x plus 3 to the what? 99. But what's the derivative of the inside? 2. So what's the final answer going to be? 200 2x plus 3 to the 99th. That is the derivative. That is the derivative. You're going to do this so often you're not even going to think about it. You effectively do the derivative of everything on the outside, and you multiply by the derivative of the inside. Derivative of the outside times the derivative of the inside. That's it. That's it. So for example, Noah, let's say I said n of x was equal to, I don't know, let's do 6x minus x squared to the 54th power. Can you tell me what the derivative of that's going to be? What do I drop to the front?
54.
Yep, and then I multiply by
2x.
careful, it's the same thing in the middle. Remember, it's still the inner function there. So do I change anything now?
No, so it would just be 6x minus x squared.
To the what? What power?
54.
Nope. If you dropped it to the front, what's it become? 53.
Oh.
And then what do you multiply by? Yep. Done. That's the derivative. That's the derivative right there. Let's say I gave you, k of x is equal to negative 2 times x cubed plus 2x to the 17th. Chris, can you tell me what the derivative is going to be?
I just pay for
Yes.
and x cubed
Yep.
plus 2x
To the
16.
yes times
3x squared plus 2.
done. There it is. There's the chain rule. There it is right there. Super easy. Imagine what this would be like if we had to multiply it out and get back to that simplification. Ugh. No. Don't. Okay, let's make it, you want to make it a little more fun?
No.
Can I make it more fun? Please? No? Okay, how about this? Ready? C of x is going to be 2 times, let's go 3e to the 2x to the 5th. What should I do first?
Move the 5 out front so you get...
Nope, don't do that. What should I do first? Yeah, so simplify first. It's the product of powers, right? So can you simplify? What would this become if I simplify it first? 2 times what? Simplify it first. 3 to the 5th, e to the 10x, yes. So now, do I have to actually, now let's do the derivative. Let's do the derivative now. What's just along for the ride? What's the coefficient? And times what? Times 2. So that's just along for the ride. Do you agree? Do you do anything with that? No. So this is just going to be 2 times 3 to the 5th. What's the derivative of e to the 10x going to be?
That's
What's the inner function? What's the inner function? What's the inner function now?
e.
Nope. No. What's the inner function? 10x. What's the outer function? E to the x. You're plugging 10x in for x. So the outer function is e to the x. So what's the derivative of e to the 10x going to be? What's the derivative of e to the 10x going to be?
10x e to the...
Not 10x.
10
10 times what?
e to the 9.
Nope. Okay, let's do this again, everybody. Let's do this again. What's the derivative of e to the x? E to the x, right? So what do you think the derivative of e to the 10x is going to be? E to the 10x times? Times what? The derivative of the inner function. What is the inner function? Times 10. The inner function is 10x, so what does it kick out? It kicks out a 10. So let's go back over here. What do we multiply by? So it's going to be e to the 10x times what?
10.
Times 10. Exactly. Once you recognize the inner functions, it becomes really straightforward. Let's go back and do some of the straightforward ones. Sound good?
So the inner function can be also an exponent?
Yes, absolutely. It can be anywhere in there. Absolutely. Yes, because e is a constant. You can't take that out. You can't take that out.
Would they ever have like multiple inner functions?
Absolutely. So that's one thing we're going to get to is how many times can you put a function inside a function? How many? There are 3 amounts in math. 0, 7, and what? Exactly. So how many times can you compose functions? As many times as you want. So could I do j of c of q of r of x? Absolutely. Absolutely.
Wait,
No, we're going to do some of these. No more questions. Do. Get to the board, everybody. By yourself with a marker. Let's do 2 over here and 4 over there. 2 over here and 4 over there.
Why am I lonesome with a marker?
No. You drop to the front. 7, 4x squared plus 1 to the 6th. This right here is the derivative of the outer function. Then what do you have to multiply by?
The inner function?
The derivative of the inner function. What is the derivative of the inner function?
8x.
Kids, you got it? So to the 6th, so it's just what? 8x. Okay, let's move on. This one right here, go. You have 5 seconds. Don't write it down. 5. Do this. Oh, look, it's just 5, 3x cubed plus 2x plus 1 to the 4th times what? Alex falling over. That's great. What's that first step? Go from radical form to what? Exponential form. So 2x squared plus 3x minus 4 to the what power? So when you do that, you now end up with 1/2, 2x squared plus 3x minus 4 to the times what? 4x plus 3. Alex, no more leaning on the chair. Seriously, push the chair in. No more chair. No more chair. Just say it out loud for me. On the count of 3, tell me what the derivative of that is. 1, 2, 3. Done. Right there. 2 times. 1, 2, 3. Right. On the count of 3. 1, 2, 3.
2x.
The whole thing.
Expect more people to talk.
Okay, say the whole derivative out loud. Ready? 1, 2, 3, go.
2x.
2 times e to the 2x.
Yes, done. 2 times e to the 2x. Done. What is the derivative of e to the x?
E to the x.
E to the x.
The derivative of e to the 2x is the same thing, but now what is the derivative of 2x?
2.
You've actually been doing this is really important, everybody. You've been doing the chain rule. You got to practice that at least. Like this right here. You see this? Have you seen me doing this all the time? This is like
That's so cool.
This is
That's
sophomore
so
English high school year. So I don't know how my teacher did not like throw me out a window, because for like an entire semester I was going like. Not kidding. I'll teach you later. You've been doing the chain rule the entire time. Here's the thing. E to the x, everybody, is actually, you've been doing this. ln e times e to the x times the derivative of x. What is the derivative of x? 1. It's been invisible the entire time. You've been doing the chain rule the entire time, but what is the derivative of x? 1. It's been there the entire time. Okay, so this is just 2e to the 2x. Nice. Okay, let's see if we can get more fun here. That's not fun enough. Here we go. That's a multiplication sign. That's a multiplication sign. Go. Do it. I'll give you those are valid answers, but really to begin with, how many things do you see? 2 things. There's this one and this one. And what are they being done to each other? They are being... So what's the overall rule you're going to use? The product rule, okay? So watch. Watch carefully. Don't write anything down. Just watch, for example. If we use the product rule, what is the product rule? It is the first times the second plus the first times the... So don't write anything down. Watch this. It's going to be the derivative of the first. Let's write the whole thing out. The derivative of the first times the second plus the first. We're not doing the derivatives yet. Plus the first times the derivative of the second. Did I write that out properly? I haven't done the derivatives, but let's do them now. What is the derivative of this? 2x. So this part is done, right? That's pretty nice, right? Well, we bring this down. That's just x squared. But what do we have to use to do this one?
The other thing.
The chain rule. You have to use right here. What do you have to use?
Chain rule.
The chain rule. Exactly. The chain rule.
So is that what we got up here? That
Hold on. Yeah, I'm saying you saw pieces of it, but you need to do it carefully. So now let's do the chain rule in this. What's the outer function?
squared.
E to the x is the outer function. And what are you putting in for x? X squared. Again, there's other ways to compose it, but this is the way you should use. So this is going to be e to the x squared times what? What's the derivative of the inner function? Times 2x. So the final answer is going to be 2x e to the x squared plus, and how do you think I would simplify this last piece for me? I said you wanted to know when you simplify and when you don't. What do you combine there on that last term? So it's going to be 2x to the what? Times e to the x squared. And this right here would be the final answer. That would be the final answer. This one's just like the other ones, but it's this with e. E is really nice, right? So it's just e. Oh, don't want to use the highlighter. What is it? E to the what? Yeah. 2x plus 1 times plus 2. Exactly. Now I have a corollary to this. Let's make this just one small change. Let's add one small change. Let's say I said y is equal to, I don't know, 5 to the x squared plus 2x plus 1. What's this derivative going to be? Anybody want to answer this one for me? What's it going to be? Y prime is going to be what? ln 5 times what? 5 to the x squared plus 2x plus 1 times what?
2x plus 2.
Yes.
Do we have to use ln because it's not a constant?
Well, no, there is an ln here, but what's right here?
Yeah.
ln e.
Yeah.
What is that? 1. We've been dropping that because it's just 1. Okay? Let's practice the derivative of the first times the second. What's the first function in this case? So what's the derivative of e to the 3x? E to the 3x times 3, and then it's the same thing for the, you don't touch the second function, right? Plus what? Well, the same function, but then you do the derivative of the second. What's the derivative of the second, Chris? Chris? I mean, it is a cool name. I understand. Like, I understand. You can like appropriate other people's names and be like, nope, I'm Chris now. Choose another name. No. Now, Alex asked you a question like, should I multiply that 3 in? If I'm testing you on whether or not you know the chain rule, what does this line tell me? You know the chain rule, right? The challenge is you can reconfigure this a bunch of different ways unless you're forced to. And one way you might be forced to is, where is this increasing? Let's see if we can do that one. Let's try that. Just watch for a second. If we wanted to know where this is increasing, we need to know where this is the derivative. It's increasing where the derivative is what? No, is more than 0. The function is increasing where the derivative is greater than 0. To find that, we need to know where the derivative is 0. So if we want to do this, we set this equal to what? 0. So we do this. So what do we factor out first? What's in? So e to the 3x times what? 3, 4x squared plus 2x plus 3 plus what? 8x plus 2. Now what do we need to do inside those parentheses? What should we do now? Well, we need to still clean it up. You guys kind of said the same thing. We need to take this and we need to clean it up. To clean that up, we're going to need to do those things you just said. We're going to need to multiply. So what do we end up with? We end up with 12x squared plus 8x plus 2 equals what? So then we need to keep going. What do we end up with? 12x squared plus what? 14x plus what? And then what do you hope is true about this? Be more specific with your language.
It's a nice fact.
Factors nicely. Everything is factorable. Everything is not necessarily factorable nicely. That's a really key mathematical fact that books tend to lie to you about. They're like, this isn't factorable. That's not true. Everything is factorable, not be necessarily factorable nicely. What's the one number in that quadratic that makes you kind of sad?
11.
The 11 makes me sad, but actually 11's nice because it's prime-ish. That might help. The 12 is kind of nasty because it's 2 times 6 or 3 times 4, right? So how do you test to see if something is nicely factorable? What's the test you can run? Do you remember? You can check the what? I'll write it down for you. What's this called? The discriminant. Who said that? You get that? Good job. So what's b squared here? Well, that's 14 what? Minus 4 times 11. Anybody know what 14 squared is at the top of their head?
261.
That's a good guess, but it's too big. Anybody know 14 squared? What is it? Come on. Do it.
161.
Come on, what is 14 squared? Come on, help me.
It's end in a 6.
It does end in a 6. Yeah. No, but that's a good thing to remember. It ends in a 6. What is it? No.
226.
Tell me what this is. You guys have 10 seconds to figure this out on the board. Go.
196.
Yes, yes.
I was saying 186. Forgot to carry that.
196. So you have 196 minus what? Tell me what that is. Go. You have 10 seconds. Go, go, go. Come on. So here's the thing. This is 528. The only thing you care about that this is what? It's less than 0. So if the discriminant is negative, does this ever cross the x-axis? It never equals 0. It never equals 0. We just asked the question, where does that blue box cross the x-axis? And the answer was, it doesn't, right? So is that quadratic facing up or down? 12x squared. Is 12x squared facing up or down?
Up.
Why up?
Because it doesn't go past x.
Well, it could be all below, right? Is it all below or...
Positive.
12 is
How do you know that?
11 is positive.
No, careful. 11 doesn't dictate it. It helps. The what? The 12. The leading coefficient dictates the direction of the parabola, right? 12 means it's facing up. Negative 12 would be facing down. E to the 3x is always what? Positive. This is always what?
Positive.
So the derivative is always?
Positive.
So therefore this function is always what? Increasing. Hold on, but just focus here for a sec. 3e to the 3x is always positive. So is that 12x squared plus 14x plus 11. So this whole thing is always what?
Increasing.
It's always positive. So therefore it is always increasing. You need to answer it in pieces. So if I asked you to answer